Hi there, I'm Deep Dylan. Welcome to your AI Injection, the podcast where we discuss state-of-the-art techniques in artificial intelligence with a focus on how these capabilities are used to transform organizations, making them more efficient, impactful, and successful. Welcome back to your AI Injection. I'm Deep Dylan, the host and a data scientist here at Xionics. So this week we're going to talk about understanding conversations through human-machine synergistic interactions. I'm joined by our regulars here, Bill, Constantine, and Carsten Tusk, both data scientists here. How are you guys doing today?
Great. It's a beautiful, beautiful day outside, actually. How are you doing, Carsten?
I'm doing well. It's a little cloudy up here. I'm currently in Haines, Alaska, enjoying the scenery and thankfully escaping the heat waves.
So I'm going to go ahead and start us off here with a few examples. So you've got a communication system that might help some kind of famous politician or a star or somebody communicate with millions or thousands of constituents or fans. Say they get a large inbox and they have to try to make sense of it. So another case, you might have a product or a service that gets free-form reviews. You might have an email system that conducts conversations with people, maybe after they fill out a form, stop by a booth, or have some kind of other interest expression in a business. Another one, let's say you've got an insurance company recording sort of millions of audio transcripts of conversations regarding a claim. One last one here is maybe we've got a trend prediction system. With that, I'm going to just kick it off here. What makes training a machine to understand communication sort of different from other machine learning problems?
One of the things that I've experienced is the level of noise in this type of data. The way that people communicate via text is completely different than the way they communicate when they're writing an essay for their teacher at school, which is maybe completely different than how they might communicate with Facebook and so forth. So the flavors in which people communicate presents a challenge in terms of trying to understand what those folks are saying when you have all these different ways of presenting that information. So I think that can be quite a challenge.
Sometimes emojis, for example, you can have a whole conversation just through emojis, and it's clearly like different than, a professional publication or something.
Yeah, one other big form is the difference between oral and written text. Like our conversation is being recorded right now. We have such great brains in our heads that we can fill in the context of things. Written form is another area where we have to be a lot stricter typically.
Carsten, maybe you want to give us a description on how we even take text and represent it, that we can even begin to formulate, machine learning problems with it.
We have to take our text and we have to transform it into some sort of numbers. And typically we start with a term document matrix. Let's take tweets. Say you have 100 tweets. You kind of want to turn that into a thing that your computer can understand. So the first thing you want to do is you want to actually see what kind of words are in my corpus. And then you encode each document basically according to this vocabulary that you just built. And at that point, then you have something that you can start feeding to machine learning models. It all boils down to having certain methods and tricks how to take your language and transform it into basically vectors. Very often when we talk about understanding an AI, we're giving AI a little bit too much credit because at the end of the day, it's just pattern recognition. Even the sophisticated models like GPT-3, etc., that we see, they can't reason. They don't reason at all. They just have seen a bazillion patterns. And so after you consume all the correspondence on the web, of course, you see repeating patterns and you see things that might make sense, but they only make sense because they have been seen so often.
All that's true, but I feel like part of what's happening with AI advancing is we're redefining what intelligence is. 20 years ago, if you asked me, hey, is something really intelligent if it can translate all languages into all other languages pretty well? I would say, oh, yeah, because I only know a couple of people that can do that with a large number of languages, and they're definitely intelligent. We didn't have an idea that pattern recognition could just create the illusion of intelligence at such a massive scale. So we've since redefined it and said, well, hey, maybe language translation just doesn't really require intelligence. Bill, maybe what does it mean to extract information at the document level, and then maybe morph us towards what it means to extract information at the corpus level or at a higher level?
The sort of the starting points that I've done in the past is to take a document and you can do, like you said, you can take individual sentences of those documents and split them up into words. And you can even split them up into entities that have different meanings. Like you can do this thing called, let's find all the noun phrases within a sentence. So noun phrases, you can think of it as like a noun in a sentence, but on steroids a bit. It's officially like a small group of words which contain that noun, but they have like modifying words around it. So if you have a sentence like the new pink bike is mine, then the noun phrase there would be like new pink bike. You can gather the collection of these noun phrases and you can see, for example, you can do simple things like how many times that noun phrase appears throughout that document. So if a lot of that conversation, revolves around the fact that they're talking about this new pink bike, you already start to get a sense of the importance of that particular topic to that document. That, we're talking about something related to bicycles, it's this one particular bike that's important and so forth. So you can kind of build almost like these histograms or these counts of these noun phrases and bubble those up at the top to sort of give some sort of basic idea of what seems to be the predominant conversation, essentially.
Yeah.
Carsten, do you want to go from there?
Yeah, kind of. So then you have your pink bike, and you kind of know on an abstract level that a pink bike is a vehicle, right? Some sort of a vehicle. And it could even be a sub-sort of a vehicle. It's a manual vehicle. It's not a powered vehicle. And so you can take your noun phrases and you can assign them to entities and kind of like level it semantically onto a more abstract level than these concrete manifestations of those entities. And that can help you kind of like make sense of what the documents are about in a greater sense, or even group common documents together. If you have groups that talk about vehicles, they're not necessarily all pink bikes, but there could be other vehicles, but they still have that in common. And so it's all about taking the highly detailed information and kind of like leveling it up a little bit on a semantic level to get more abstract categories that you can then better group together and get a general sense of what your corpus is about if you go one level up.
Mm-hmm. Yeah, so I think like there's sort of different kinds of things we can do with the document level. Like, there's this kind of entity extraction or this people, places, things extraction. A lot of times that involves having to resolve anaphora. So that's things like he, she, it, the lawyer, the company, etc. That might be explained kind of in the document prior. In machine learning language, sometimes we might be just pulling out sentence level insights where a given sentence kind of categorizes. I know that, we've done that in a lot of different cases. If we're trying to get a machine, like in one of our, we had a client that builds a system for folks like Beyonce and Metallica to talk to, their millions of fans. And there's, a whole hierarchy of things that people are talking about, but being able to, those tend to be terse statements coming in from fans that are, in this case, just texting their stars directly. I know, Carsten, you and I were involved for years building kind of a deep relationship extraction engine where we're looking at grammatical things. If we think back to 7th grade grammar class, somebody doing something to another thing or person. So, Jane hits the tennis ball, on Tuesday during her match. We do this whole kind of grammatical decomposition. So there's some kind of relationships extraction there. There's event stuff. So there's a whole bunch of different things. And then you can kind of bubble it up and start asking stuff at a higher level. I know, we were analyzing a lot of reviews coming into physicians performing surgeries. And it's one thing to tell, a physician, hey, the sentence level, we have these 38 mentions of somebody saying something positive about the way you perform this surgery, and 100 and something describing something negative. Of those positive things, they gave these really specific granular examples of, you have good bimanual dexterity, for example. That was something of concern. Those are all like really powerful to tell a physician, but it's even more powerful to kind of contextualize it across a corpus, or in this case, other physicians. So telling them, hey, it turns out that 53% of your feedback coming in was, positive, which sounds good, but, it turns out that was like 30% below the mean for, other physicians, which, causes them to kind of jump up and pay attention. So these sort of aggregated insights tend to be pretty important as well. I don't know, can you guys think of some work you've done maybe in the past or that you can think about where it's not just important to pull out an insight at a low level, like in a document, but where you learn something important at the higher level?
That's a tough one. The one thing I was going to mention in the context of coding higher level concepts is search engines. So you have a whole corpus about people doing things that say, well, one thing that we worked with was I think in the public domain back then, the Enron email corpus, when that whole scandal happened.
Yeah.
You could basically encode these things and start searching for, certain relationships, like who drinks beer, who travels to Seattle. And you can imagine that if you're searching for certain patterns, like people that travel to Seattle and then rented a car and then, I don't know, did something else. It's a great way to build this network of actions and analyze it afterwards. So that's something you can do on a corpus level that is not necessarily in each individual document.
So we're working on a project right now, try to understand what are the various anti-vaxxer positions. We're actually in the process of building out a corpus right now. Carsten, maybe just describe the corpus that we're building here and what are the kinds of things that we can do with it and why this might actually help.
So we basically went to social media. We're looking at YouTube, Reddit, as well as Twitter. We're basically just extracting social media posts that have something to do with vaccinations. And we're just building a text corpus based on that. And the next steps will be to analyze that further and figure out if this is something pro or contra vaccination. And then maybe we can even identify certain subgroups in there and analyze their motivations behind their actions. We try to divide this corpus into two different groups or multiple groups and try to identify individual subgroups in there based on their language. Now, I don't really know what that's going to look like exactly, because we aren't that far yet, but that's the goal.
Yeah, I know we've got this. It's kind of interesting. So it turns out that people have different reasons for taking an anti-vaxxer position, right? The idea is, if you're a public health agency and you're trying to convince somebody, you kind of want to speak to the lexicon of their concerns.
Maybe you could speak a little bit about the process of what you do with text data like that to build something that was used to detect sentiment. So sentiment is, that person said something positive, that person said something negative, that person was mostly neutral. How would you teach a computer to infer things that we sort of naturally figure out on our own?
Lots of samples. You basically start with examples of what are positive expressions. You start with samples what are negative expressions and whatever type of expression you want to identify. And then you just basically annotate a whole bunch of them. And then you simply train a classifier. So that's the boring and simple version that you can go.
There's sort of limited utility around sentiment sometimes. And a lot of times people want to know, well, what are they being positive about or negative about? So if you say, I hate, Joe Biden, or I hate Donald Trump, or I love Joe Biden, or I love Donald Trump, in those cases, there's clear positive and negative sentiments about a thing. In this case, that, the person, the actor, the politician. So in those cases, I know we did this years ago in an earlier startup of ours where we did a deep grammatical analysis of the text. And based on the deep grammatical analysis, if you think back to 7th grade grammar, I hate Joe Biden. The subject is I. The verb is hate, or the predicate, and the target or object of the hatred is Joe Biden in this case. And then we would do things like associate a whole taxonomical hierarchy around the entities. So we would know, for example, that Joe Biden's a politician, that specifically is the president, specifically of the United States. Then you can kind of with all that stuff, you can now start to contextualize your sentiment. And you can start to look at what is the sentiment score, positive and negative, for presidents, over time, or for politicians over time. And you can start to kind of bubble up. So this kind of ability to leverage the hierarchy in conjunction with some grammar, in conjunction with some sentiment and some machine learning, kind of starts to get you much more exacting and potentially helpful things than just kind of a generic sentiment.
And I want to put a shout out into the systems that we use here at Xionics. We have this hierarchical annotation that we use when we develop models around text. You're not just labeling something as simple as good or bad. We have this whole hierarchy that allows you then to delve much deeper into the dirty details. Not just good or bad, but maybe certain reasons why good or bad and so forth.
You're listening to Your AI Injection, brought to you by Xionyx.com. That's XYONIX.com. Check out our website for more content, or if you need help injecting AI into your organization. Why don't we pivot to this question of labeling, getting training data? So the question for you guys is what are some of the challenges in building effective training data for these systems?
What's kind of tough is that if you're looking to build out a model for these things, and sometimes whatever you're trying to do to gather data, it may be publicly available, but you might be limited in your access to it. It might be private data that you don't have access to it at all, or it might be just rare data. So in those cases, there are these great alternatives. There's a lot of detail behind them, but there's actually this great AI-based techniques for simulating data. But you might
just have to be very careful with the simulations. I just want to throw that in. You have to be very careful that you don't introduce a bias into your system. Because sometimes the simulation is too limited and it has a certain point of view. And then if you use that to train your data or to simulate your data, all your model learns is basically a copy of your limited simulation. So to use these techniques, be aware that you have to use something that's really broad and encompasses the whole scope of your domain, basically.
So going back to the question of the challenges around getting sufficient examples and getting good examples for training these models. So Bill, you mentioned this idea of leaning on these trained systems that can actually generate language. But another direct and straightforward means is simply to have humans label the stuff. When humans label stuff, you got to figure out, are all labels created equally? So if I'm just randomly sampling from millions of documents for a particular category, it can be sort of a waste of time at some point. What happens is we have these models where they have areas that they fail in that are way more in need of new examples than the areas that they're doing just fine in. So let's say that you've got some strong cues like hate and love, and the model is doing just fine in those intense cues, but in much more subtle cases, you find out the thing is inevitably doing worse on. So does one of you guys want to speak a little bit to the idea of active learning in this context?
Yeah, sure. I mean, it's just like you said, you don't just need samples, you need the right samples, right? You need to pay attention to the classes that are underrepresented. Try to create a very balanced training set. And then ideally also concentrate on those sections where your model gets it wrong, like you said. And so that is the problem, finding false negatives. And it really depends on your problem scenario, how to do that. You got to find a way to find the things that you didn't find, in other words.
What's the evolution like from the very beginning of a project? Do you find categories, have more or less problems as you kind of progress? What have you sort of experienced there?
Yeah, you can start with a problem where you have a bunch of classes that you're looking to identify within text. Let's say that you're looking to identify, for example, folks that aren't really doing well, and you're looking to assess their mental state. So the types of things that they're saying might be indicative of them being, for example, depressed or have a lot of anxiety and so forth. You can divide that up into this person is super happy, this person is depressed. Those broad categories don't really do a lot of that rich texture of, mental health justice. And you might start off with something quite simple like that with just a couple of main categories, and then tell your annotators, hey, I'm looking for you guys to go through this text and label these according to these couple of main categories that I've chosen, these broad stroke categories. But they're ultimately probably going to come back to you and see all the subtleties in how people communicate and see, this person sounds like they might be depressed, but I actually think they're being sarcastic. Or this person is maybe quite happy, but they're just being very cynical just for a brief portion of their text and so forth. And as you get more of these labels into your system, the models will start to learn more and more. At some point, you can take all of those labeled data, you can divide it up into something you train with and something you test with. And you can see, how your models are doing with each one of these different labels and each one of these different categories that you've had.
In the same context, you talk a little bit about annotation bias. Because unless you have a very crisp scenario where you have annotators distinguish between cats and dogs and elephants, what belongs to a label is not very clear. You will find that each annotator has a different opinion of what you mean. And this annotator bias goes into your training data, We have run experiments where we compared this, and what we found in this particular project was that very, very rarely more than 3 annotators would agree on a label across the board. And that was because the categories, they had a little bit of like human interpretation in them, where you had to make a decision. And the annotators weren't all on the same page. And you'll see that reflected in your classification results later. If you look at your confusion matrix, you see a certain distribution there. Text is not black and white, what the meaning of a sentence is, but images are not either. Like I said, if it's not cats and dogs, if it's like a real world example of something that is not black and white and not easily distinguishable by a human, then you have a lot of annotator bias and everybody interprets it in a slightly different way.
One of the things that I've seen be a way to address some of this category boundary definition. So let's say you're a famous politician, you're getting thousands of emails a day, coming in. And let's say that they're kind of like bombing you with stuff. If we ask our annotators like, hey, tell me every time somebody's providing some feedback, that's kind of an awkward thing to define sometimes. But one of the things that we found is if you go way down and you give them really specific examples like, hey, you are doing great or you're doing terrible, like that's, let's say, a very low level label, communicating that to annotators can be quite straightforward. You can give it to the labelers. Labelers can go out, formulate some keyword searches to help get the category kind of juiced and off the ground. But one of the powerful advantages is if you get them to do that at that granular level, then that can serve as an example all the way up this hierarchy. One of the things that we do when there's ambiguity is we'll say something like, look, if you don't know for sure whether this is about including a public option, but it's about healthcare, or it's a suggestion about legislation, just label it according to the highest level thing that you can. And then that kind of like lifts the burden from the labelers. And they're like, oh, okay, well, that's, I don't have to maybe argue about the category boundary. And you can sort of organically like punt that to another day.
So the thing that they're sure about might then inherit this upward hierarchy, so they don't have to worry about it, right? That's pretty cool.
The other kind of concept that's related that we found to be powerful is sort of like holistically label within a space, but then you might prioritize within there. So for example, in this political case, like let's say that we know that there's some healthcare legislation coming down the pipe and we want to give really granular feedback. We might juice the models to give very granular feedback in healthcare, but retain their generalized feedback in other areas. And then in a couple of months, we might switch it. So this lets us sort of evolve the depth of understanding of the model over time and kind of tailor it according to the business needs. And that's another really powerful thing that you don't really see coming out from like generalized models out of the big tech companies. Or what you'll see is a lot of individual companies they'll miss potential product and business opportunities because they're overly constrained, or they'll make overly broad category definitions. Sometimes for years, we've seen this, which will end up kind of blocking things out.
So it sounds like you're saying this hierarchical taxonomy that we have in place just facilitates lots of adventures in the future for different types of modeling exercises. Is that a one-liner takeaway?
I think so.
Yeah.
Like not everyone has Facebook or Google's budget. So they're getting like hundreds of thousands of labels, and they're just like in a totally different universe than a startup or a project that's focused in a particular area and has like a judicious budget, that they have to like allocate. When we were talking about synergistic human and machine interaction, I think we're talking about human interaction, start with maybe a random sample, machine goes off, runs through the back catalog of millions of documents, emails, text. Humans are now presented with what the model thinks is a category, like include the public option in healthcare legislation, or let's relabel these ones that the model screwed up on. And the humans kind of have to balance that, as Carsten is suggesting, because you don't want to only go towards model correction, or you could potentially just have giant blinders behind you. So you need to include, random data along the way. But in this way, you've got humans and machines kind of working back and forth. One trains the machines get smarter, they give the humans more stuff to look at, and you just kind of keep going. Eventually you understand the conversation, and you can bring all kinds of capabilities to your product.
What do you think, how much real understanding we're doing?
None.
I would agree with that.
I mean, I don't think patterns are understanding. That's a powerful word to use. It's provocative, but Like we were working on a depression bot for a company, and I started doing some research on some state-of-the-art techniques for this depression bot. This thing was trained on a lot of these very state-of-the-art systems, and you would ask it stuff, and it was supposed to be your therapist, and you just had no moral value judgments whatsoever. And the way a parrot repeats things it's heard but doesn't understand them in any sense, that's kind of the path that we're on with these machine learning systems. At least that's my take. Like they can be smart parrots and that they can kind of like take things and parrot them in just the right way. But I remember asking this thing, okay, so do you think it's a good idea to blow up the earth? And the thing had like learned that because this is like a silly conversation that happens out on the web. So it's like, well, of course not. Why are all you humans so obsessed with blowing up the earth? But then I asked the thing like, hey, is it a good idea to eat babies on Tuesdays after going for a run or something like that? And the answer is like, well, yes, of course. Because it had sort of learned that if somebody asks something kooky and weird, the thing to do is to give like an extreme answer. And so
eating after running is good, right? So the fact that it's babies.
But, that would imply understanding. So I don't...
Right.
Carsten, you mentioned before about these generative text models and how you have to be careful about bias, but they don't have an understanding of the physics of the real world. So for example, in one of these text generation moments, I asked the model, which is heavier, a cookie or the moon? And it responded, the cookie is heavier in some cases. In some cases, it got it right. It said the moon is heavier, but you might enjoy it more because it's made out of cheese. If you think about that in the context of you're talking to a machine, that's cool that a machine could actually
formulate such a clever statement.
Such a clever statement. That's the thing about this. And this particular model is really fascinating because it's literally trained on the world's worth of data. I mean, the entire text on the internet. So if there's something crazy that you want to ask it, you're going to get something back that sounds like a human might have said that. Whether that's based in logic is totally different story.
One of the things you're bringing out is part of the art or the jujitsu of wrangling these systems into being productive and helpful. And that is, everyone has this dream of putting this generalized machine learning AI system out there to handle a generalized problem. But the reality is that sometimes we as practitioners and product builders have to put guardrails up. You can't have a generalized system that's a parrot without any real understanding. You can't have it talking to potentially suicidal patients with no guardrails. And so it's the cost of a mistake is so high and the chance of this thing making a mistake is incredibly high. That's part of what's going on, is that we've really changed the game from 15, 20 years ago, 10 years ago even. We were just trying to get these machines to do something reasonable. Now they do reasonable things most of the time. And so we're changing the way we think about them, and we're saying, well, what are the cases where reasonable most of the time is okay? Those things are getting deployed at scale. That's Google Translate. That's, Alexa understanding what you're saying and saying stuff, because it's reasonable to screw up in those contexts. But it's not reasonable to screw up and have your pacemaker just give the wrong signal at the wrong time. So I think that's part of the eye in the AI. It's a growing eye. Like it was really, really tiny 15 years ago, and it's getting bigger. But it's definitely not, intelligence in the way that, those of us who know what's going on behind the scenes can't easily spoof and get it to just fly off the guardrails and smash into a million pieces. That's all for today. Topic on standing conversations. Bill and Carsten, thanks as always for a fun conversation. I know we started off kind of trying to get our feet in the door and eventually wind up at AI taking over the universe, which is always a great to end for the weekend. Everybody, for anyone that's interested, we've got some articles on this topic on our website at xionyx.com. That's XYONIX.com. With that, see everybody next time. That's all for this episode. I'm Deep Dylan, your host, saying check back soon for your next AI injection. In the meantime, if you need help injecting AI into your business, reach out to us at xionyx.com. That's XYONIX.com. Whether it's text, audio, video, or other business data, we help all kinds of organizations like yours automatically find and operationalize transformative insights.